In this video, we're going to use the famous disk method, the volume of rotation method, to derive the formula for the volume of a right circular cone. Okay, and the formula is going to be 1/3 pi r squared h. Okay, so to use the volume of rotation method, we must use the xy plane, and as you know, we will have only one integral as opposed to triple integrals that we used in the other videos. So it might be easier for you to do it. Let's see, x and y. Okay, so what we're going to do, we need to have a function of x for simplicity that we're going to revolve around the x-axis. Okay, so we're going to revolve a function that will determine an area, and we're going to revolve this area around the x-axis to make a right circular cone. So what you want to do, you want to have a right triangle, which is a two-dimensional snapshot of 1/2 of the cone precisely. Okay, a right triangle, and this part is the h, the height of the cone. This part is the radius, the base radius of the cone. So now speaking of the coordinates, this is the origin, 0, 0. This is h, 0, right, this vertex. And this vertex is h, r. So now the function that we're going to use will be the hypotenuse, the line segment. Okay? So the line going through this line segment, in other words, will be the function of x that we're going to need to determine, right? And why we're looking for the function of x? Because using the disk volume of rotation method, we know that the formula is pi, the integral from x is equal to a to x is equal to b, squaring the function of x dx, right? That's the formula. So that's disk method formula for volume. So now we need to determine the limits of integration for the x variable, right? And that's already easy. You can see the graph that you drew is going to be from x is equal to 0 to x is equal to h, right? So we already did some work. X is equal to 0 to x is equal to h. And it makes sense, right? Because we must deal with the r and h only as our final answer when we derive the volume of the right circular cone. So now what is the function of x? To get the function of x, in other words, line passing through this line segment, we need to use the point slope formula. But we need to determine the slope, right? The slope will be, and actually we're going to use this equation, y is equal to mx plus b. Why not point slope formula? Because we already have the y-intercept, which is 0, right? So that makes it easy. The b value is 0. So b is 0. So we just need m to derive this equation. So to find m is going to be change of y divided by the change of x. So we're going to use these two coordinates to find the slope of this line. So change of y is going to be r minus 0, right? R minus 0 divided by change in x, h minus 0. So that's basically r over h. So the equation is equal to r over h x. And keep in mind that the function of x is exactly y, right? And that's r over h x. So now you have found your function of x, and you can input it into the disk method formula for the volume. So you're going to get r over h x, square that, and then dx. So then it's going to be fairly easy. Let's take the r and h out. So we're going to get pi times r squared over h squared, right? Because this whole thing is squared, integral from 0 to h x squared dx. Right, we took it out because r and h are constants, right? They don't change. They determine the specific circular cone that you're going to have, right? So we took it out. Only the x is the variable. Okay, so now what happens then? We have pi r squared over h squared multiplied by 1/3 x to the third from 0 to h, right? Because the antiderivative of x squared is 1/3 x to the third. And that turns into pi r squared over h squared multiplied by 1/3, and then we can just input the h, the 0 doesn't matter, so it's going to be h to the third. And what happens? H to the third goes away, becomes the h, this guy's completely gone, so we're having the final answer, 1/3 pi r squared and then h. You have successfully derived the volume of a right circular cone using the disk method, the volume of rotation method. Thank you so much for watching, and I'll see you in my next videos.